In this video, I want to talk about a new structure called Bsp Tree. I believe it's not being taught in the class. And for the Bsp Tree, the usage of the Bsp Tree, one is to define which part of an object can be rendered, and the other one is used for the collision detection. However, for the collision part, because creating a BSP tree is very time consuming, so most of the time it won't be used as to doing collision detection with two moving parts. However, if one of them is static and uh, for example, if one of the objects located here is always there, but now another moving object tries to hit it, if we have several such objects, we can put it in a BSP tree, and now we can use for time for collision, and it's very efficient to do it. It takes about log n time. However, if the BSP tree is constructed not very efficiently, it also can reach the maximum of ON time, which is not good. And first, we want to look at the definition of Bsp tree. The Bsp tree it is binary space partitioning tree, and it's an ND space can be divided into can be divided by an n-1D hyperplanes. So, for example, we want to divide a 2D plane. We can use a line, so it's 1D, and we can mark this one is plus and this one is minus. If we have an object here, now we can further divide this. This is the first plane, the first one, and then we have the second node, and then we have a third one. And if we divide it plus negative, negative, and the third one plus negative, so we can easily locate this one in the tree structure. And the BSP tree have different types. One is node storing BSP tree, one is leaf storing BSP tree, and the third one is solid BSP tree, or solid leaf BSP tree. And these two parts are very useful in the real world. This one is not that useful, and I will explain why. For the node storing BSP tree, we store, when we see the tree structure here, we store the nodes, for example, the edges of a polygon. We store the edges in the tree structure, and each plane is also have some edge on it. So we don't have to save the dividing plane. For example, this one, first we choose the dividing plane like this through AG, and in the other types of the BSP tree, we have to save this dividing plane in the node. However, when we see the plane here, we can say, okay, G is collinear with the plane, and A is also collinear. So we just put A and G in the node. That we don't have to save the plane. And based on this one, for example, this one is positive and negative. So positive, negative. We can see some of the edges located on the positive part and the other one located on the negative part. But the problem is for the edge D and J, they are divided by this plane. And for example, this one is D1 and D2 and J1 and J2. They have to be stored on different key structures. Actually, it's exactly the opposite tree structure. So when we further divide it by this plane and this plane, not the upper part, only this one is the lower part and this one is the upper part. When we further divided it, the J1 and J2 are totally different, located on the tree structure. So this one is very bad for collision detection. because we don't know which, if an object hit D, okay, hits here, we don't know which uh, structure which node we should go through. And the good thing is, well, it looks like a good thing because we can save the faces. We can save the planes or the edges in the node. So we don't have to save this this edge or this plane. Use some extra space to save it, but we can use the original nodes to save it. However, the problem is when we use the original surfaces, we usually divide some other edges. So now the D and J are divided. So it may use some extra space to save the whole structure. So next one is the leaf storing Bsp tree. This one looks much nicer. And we can choose a plane. We don't have to choose someone with collinear with the original edges. We just choose anyone we want and divide it into two parts. One is plus and one is negative. This one is plus and negative. And then we save all the edges in one, in this one. This one is the node, the leaf, and this one is the leaf. So we can save it. And further on, we can divide this part, use some other ones. The example use this plane, but we can use other one. We can use this, or we can even use a plane like this. If we use a plane like this, the edge F is located on the plane, so we can define if someone located on the plane, we can put it either on the positive one or the negative part. So that's totally defined by us. And okay, the example here is located on the L. So we put L on the negative one. And this one is very, so for each edge we can easily put it under a one tree structure under this one. We don't have to go through all the leaves, so it's good for the collision detect, and it is very time efficient. It takes only log n time. Okay, and the next one is we're going to talk about the solid leaf Bsp tree. The solid leaf one, we just define if the object, if this part have the object or not. So it's only some binary, actual binary data. So for example, empty means null or zero, and solid means one. So it's and positive, negative, also some binary data. But with this binary data, we can very easily to define this part and all this part if it's solid or empty. So for example, this part we can see the tree structure plus negative, negative goes to solid. So plus, so this part and negative, this part and the negative. We can easily find all the edges of the the area. And because it's so well defined, it can be used to get a volume of the whole structure or the area in the 2D part. And no geometry is stored in the tree. So we can say we only save some binary the data. And for each node, it's for each node 1, 2, 3, 4, 5 is some planes that divide the whole structure. So, and we can say it's very good at collision detection because all the edges are well defined by the whole structure. The problem is when we do this, we don't know if the node is A, B, C, or D. We have lost all this information. And with this one, we have this information, but for example, D, F, we have this information, but we don't know the area or the whole structure of the object here. So we always combine them together with a hybrid Bsp tree. For hybrid one, we combine solid leaf and leaf storing Bsp tree together. So it is very good for collision detection. And we can take advantage of both. So for building the Bsp tree, we have to do three things. The first one is we have three steps. One is to select a partition plane and then partition it to two sets. Then recursively do that, the partition into subtrees. And first, the most important one is partitioning the plane. When we have the 2D object here, we don't want to, or we can draw it, okay. We don't want to partition it as for this one plus negative, and for the plus part we have nothing, and for negative we have something, and this one plus negative. This tree structure looks not quite well balanced and not well designed, because all the objects for the tree structure it looks like this, and the object looks located here. So it takes on time and it's not well balanced. So the most important thing is we have to minimize splitting. So if we choose then plane like this plus negative, we can easily find, okay, this part has something and this part has something. So now we can define this part very easily and this part also very easily. So minimize splitting and maximum balancing. Okay, what I talked about is maximum balancing, and also I believe this one is, if the first one divides the whole object into two, is probably minimize splitting. And when we do the partition, we can use some auto partitioning and manually. Okay, the heating hinting plane. Well, there is a good example here. For example, we have a 3-story house. We want to partition it. We can use the floors as the heating plane. So everything just in this floor, they can be further divided, but nothing can cross the heating plane. So this one may be more efficient when when we use it actually. And the auto ones, they have some crazy method to define how to create a well balanced tree. And the usage of a Bsp tree, because as I have said, it's not very good use for detecting two moving objects. However, if we have some static objects, we can easily define them using the tree structure and to see which object is located in which structure. If we have a point here, for example, the first point detection, if we can easily find if the point is located on one object or it's not. And if we move the point like this, it's a ray structure. So we can also detect if at some time of t, if the ray hits an object or not. Okay, and that is what I want to talk about Bsp tree. So for conclusion, we can do some collision test. However, I believe in the modern world, this structure is used less and less, and we have some other very good structures to detect the collision, even in the real time for both of the objects are moving. However, I believe this one is not a bad idea to do the static ones, especially we have thousands of static objects there. Okay, that's it. Thank you.